Section 5.2. It says the function is the sine of x. We're supposed to do a Riemann sum with this partitioning and these points of concern. So this is basically saying we have a sine curve. And this is pi, and this is 0. Height is 1 at the max. And we're going to partition this up from 0 to pi over 2. So that's only this part right here. And we're going to partition it at pi over 6. So if this is a whole pi and we split it in 6 parts, 3 of them have to be in here. So 1 would be there, 2 would be 3, 4, 5, 6. So there's pi over 6. And here's 0, pi over 6. And this would be 2 6, which is 1/3, which is what that one is. And then there's pi over 2 at the end. So our rectangles are going to be from 0 to pi over 6, from pi over 6 to pi over 3, and from pi over 3 to pi over 2. So they're all equal width. Each one is a width of pi over 6. And then I got to take it times the height in this interval. And the height I want to use is neither left nor right. They say use at 0.4. So I'm going to go to 0.4. Let's see, this is 3, so that's a 1.5. So that's about 1. So 0.4 is about there. So I'm going to go up to the height of the curve and make a rectangle that full width of the pi over 6. So most of it will be over, some will be under, and that's what I'm going to use. So I'm going to take this times the sine, because the height of the curve, the height is sine of 0.4. And then for the second one, I'm going to go from there to there, which is still pi over 6. And I'm going to take it times the sine of, they tell me to use 0.7, which is somewhere in here. So I'm going to go up to the curve and make a rectangle, the full pi over 6 wide, and go up that high. So the height would be at whatever the sine of 0.7 is. And then for the third rectangle, I'm going to use 1.2. It's still a width of pi over 6. The height will be the sine of 1.2. And then I just got to work that out. Okay. This one, it says, sketch the areas and indicate the positive and negative areas. So I'm going from 0 to 5 of, I got a parabola, upside down parabola with a 4x added on. Let's see, that actually factors to x times 4 minus x. So I know from that that this parabola goes through 0 and through 4. And it's 1x squared, negative 1x squared. So if I'm 2 out, it'll be 1, 2, 3, 4 up to the vertex. And it'll come down to 1 above it. Something like this. 1 down, and then 4 down when I go 2 out, and so on. And if I'm going from 0 to 5, I've got negative area here and positive area here. Okay, that's all they wanted me to do on that one. 41. I got another parabola, and I'm going from -3 to 1. But I can do this, split this up into 3 separate integrals. The constant come out of the first one, so I'm going to have 7 times the integral from -3 to 1 of t squared dt plus the integral from -3 to 1 of t dt plus integral from minus 3 to 1 of 1 dt. This one is always 1 high from minus 3 to 1. That's a width of 4 by 1, so this area is 4. This one, we know that if it goes from 0 to 1, we would do b squared over 2. So if we put 1 in there, we get 1/2. That's from 0 to 1. But we need to split this up into two pieces. So we're going to go from 0 to 1 and from -3 to 0. But to use this rule, it's supposed to go from 0 to a number. So I'm going to flip this one, 0 to -3, which puts a negative on it. So to do the -3, I'm going to put -3 in there and square it. That's 9 divided by 2 with a negative on it. -9 over 2. And same for this one, I got to split it. So for the 0 to 1, I'm going to have 7 times, and the t squared rule is b to the third over 3. So I'm going to put 1 to the third over 3, 1/3. And I'm going to subtract because I'm going to switch it to be 0 to -3. So I'm going to put -3 into this. So I'm going to get -3 cubed over 3. And then take the negative of that because I'm switching it to be not from -3 to 0, but from 0 to -3. And then I'm going to add these up, and I'll have my answer. I'm going to figure this out times 7, and then this will be just a -4 because that's 1/2 minus 9/2 is minus 8/2, which is 4. Plus 4. Those are going to cancel, so whatever that works out to be is my answer. This one, it says from 0 to 5 of this. Well, I can split this up into two integrals, and I can pull out the 2, so this will be 2 times the integral from 0 to 5 of f of x dx. Minus, I can pull the 1/3 out of this one, 1/3, the integral from 0 to 5 of g of x dx. They said the integral from 0 to 5 of f of x dx is 5. So this is 5 times 2, 10, minus. They said from 0 to 5 of g of x dx is 12, and so I got minus 1/3 of 12, which is minus 4, so I get 6 for my answer. And I go to this one. From minus 2 to 2 of this. So I'm going to do basically what I was just doing. I'm going to think of this as going from minus 2 to 0, but I'm going to switch it so it's 0 to minus 2. And so since I switched the order of these, I'm going to have minus 2x to the third minus 3x squared dx. And then to do the rest of it from 0 to 2, I'm going to have plus the integral from 0 to 2 of the same thing. And for the 2 would come out, so I'm going to have the integral of 2 of x to the third from 0 to minus 2 with a minus on it, and on dx. And then I'm going to have a minus and a minus, which is plus 3 integral of x squared dx from 0 to minus 2. Plus this one is going to be 2 times the integral from 0 to 2 of x to the third dx. And this one's going to be minus 3 integral of from 0 to 2 of x squared dx. Now the x squared is b to the third over 3. So that's minus 2 to the third over 3 times 3. And x to the third goes to x to the b, or minus 2, to the fourth, b to the fourth over 4 times the negative 2. And so we have plus 2 times 2 to the fourth over 4 for this one. And then we're going to have minus, and this will be the b. And the square goes b to the third, so 2 to the third over 3. That's what this would be times the negative 3. So we get 16 divided by 4 is 4 times 2 is negative 8. That's a negative 2. This would be negative 8, and the 3's cancel. And 2 to the fourth is 16 divided by 4 is 4 times 2 is 8. And 2 to the third is 8, and these cancel, so minus 8. So I get minus 8, plus 8, minus 8. So 2 of these cancel, and I get negative 16. 57. So if 0 to 1, so if f of x, the area from 0 to 1 is supposed to be 1, and the area from 0 to 2, wherever 2 is supposed to, all of this area is supposed to be 4, so this means there's 3 from 0 to 1, from 1 to 2, since the area from 0 to 2 is 4 and 0 to 1 is 1. So there's 3, and then from 1 to 4 is 7, and if we got 3 here, that means 4 more there. So what's the area from 0 to 4? 0 to 4 would be 1 plus 3 plus 4, or 8. Now it says using these same things again, that's what this is meaning. We're supposed to find it from 2 to 4. Well, 2 to 4 is 4 because 1 to 4 was 7 and this is 3, so that's just got to be 4. Okay, and 62. So we got f of x, and we know the area from 2 to 9 is this. That's what this area is. And from 4 to 9 is this area. So all of this is the first one, and just this part is the second one. So what would we get if we took all of it minus this part? We'd get the area from 2 to 4. And so that's what we're going to write, the area from 2 to 4 of f of x dx.